Hello everyone, I decided to shoot this quick video about dot and cross diagrams in ionic and covalent bonding. Before we get started, I would like to talk to you a little bit about electronegativity, that is the tendency that atoms have to attract electrons toward themselves. So let's see that in the periodic table, electronegativity increases when we go up in the period, in the group, and when we move right on the period. So note that these elements in the group 1A and 2A, they have less electronegativity than the atoms that are in group 7A or 6A, which have a greater electronegativity. So this is very important to understand how ionic bonding and covalent bonding work. We can say that these two groups, group 1A and group 2A, are metals, and we can say that elements in group 7 and group 6 are non-metals. And remember that an ionic bond will be formed between a metal and a non-metal. This is ionic. And remember that covalent will be formed only in non-metals. Okay, now, why ionic bonding is only between metals and non-metals? Because the difference in electronegativity is going to be very high. So, for example, fluorine has an electronegativity of 3.98, and lithium has an electronegativity of 0.98. So the difference is greater than 1.8. That means that fluorine has the ability to attract the electron more toward itself, and we can say that fluorine is almost like stealing the electron from lithium. Now, when we have that, we have an ionic bond. And for example, if we have carbon dioxide, we can see that the difference in electronegativity between carbon and oxygen, remember that carbon dioxide is this way, and difference in electronegativity is not that big. So electrons aren't going to be pushed toward oxygen or toward carbon, but they're going to share the electrons. So in that order of ideas, let's start with the dot and cross diagrams. And almost always in the IGCSE, they will tell you if what you're using, or the molecule, or in this case, the formula that you have, is an ionic compound, or if you have a molecule who has a covalent bond. Okay, so in this case, they are telling you that you have an ionic compound. And since you have an ionic compound, remember that ionic means that they are formed by ions. So ions have a positive charge or a negative charge. In this case, we will have a lithium, which is a metal, and we have a chlorine, which is a non-metal. And we know that ionic bond is between a metal and non-metal elements. So in this case, we have an ionic compound. And since it is an ionic compound, one of these elements will have a greater electronegativity. So let's see that chlorine here is 3.16 and lithium is 0.98. So the difference in electronegativity is greater than 1/8. So chlorine is going to steal the electron from lithium. Now, we have to complete, this is a very important command word, so that means that something that you have is incomplete, so you have to complete it. It may sound pretty obvious, but, you know. So, you have lithium here, and we have chlorine, and you have 3 marks that will be awarded for these kind of exercises. So let's see. If you have to complete something here, we know that lithium is the metal, and let's try to do the electron configuration, knowing that lithium has an atomic number of 3. So the electron configuration for the IGCSE is going to be 2, 1. So it means that it could be, or it could have 2 shells. However, after this one gives out one electron, it becomes a cation. So this electron here is going to disappear. So now the electron configuration of lithium plus is just 2. That means that it only has one shell, and you're going to have 2 electrons in that shell. So let's try to the shell here. And you will need to put 2 electrons in that shell. Now, remember that you had one extra electron here. So that electron is the one that is going to be stolen by chlorine because it is more electronegative. So, before drawing the shell, let's try to do the electron configuration of chlorine. And from chlorine, you have that chlorine is 2, 8, 7, right? So it needs 1 electron to become or to complete the octet. So in this case, you see that you have 3 shells, but lithium gave him 1 electron. So it's going to be now the chloride ion, the electron configuration is going to be 2, 8, 8. And remember, this 8 is 7 electrons from the chlorine and 1 electron that was given by the lithium. So remember that this is called a dot and cross diagram. So here I made a mistake because I put dot and this one has dots. So I need to put a cross here, right? That's why they are called dot and cross diagrams. So this is a very common mistake that happens, and this will affect your marks here. And I will explain you later why. So in this case, we have chlorine here, and we have 3 shells after chlorine got 1 electron. So we know that in this last shell, in the outer shell, we will have 7 electrons from the chlorine, which are represented by dots. So let's try to draw 7 electrons here. 7, 6, 7. And in those 8 electrons, 1 electron is or comes from the lithium. So let's try to put a cross here. That means that that electron came from the lithium. Now, lithium has a charge of +1 because it lost 1 electron, and chlorine is going to have a charge of minus because it got 1 electron. And let's see that at the end, they will have, in this case, the octet complete for the chlorine, and lithium has only 2. So you may think, okay, but why lithium doesn't have the octet? Remember that atoms want to have the electron configuration of the nearest noble gas. In this case, the nearest noble gas is helium, which has 2 electrons. So the electron configuration of lithium to be stable is going to be 2. That's why. Okay. Now let's move on a little bit. Here we have another example. In this case, we have potassium oxide. And we also know this is an ionic compound. And we know that potassium is a metal because it is on the first group. Look. So this is a metal. And we know that oxygen is a nonmetal. Okay. So they will form an ionic compound. Okay, so in this case, let's start. It's the easiest way to start doing the electron configuration. And potassium has an electron configuration. Let's see what is the atomic number. So potassium is 19. So potassium 19 will have an electron configuration of 2, 8, 8, 1. And we have oxygen here. And oxygen has an electron configuration. Oxygen is 6. So, 8. So oxygen is going to be 2, 6. And we have another potassium that will be 2, 8, 8, 1. So this is before the ionization. So we can see that oxygen needs 2 electrons to complete the octet. And potassium needs to lose one electron. Each of them, they need to lose each one electron to complete the octet, to have this electron configuration. So each potassium is going to give oxygen one electron. So the oxygen at the end, in the end, will have 8 electrons in the outer shell. So let's try to complete this real quick. So since we know that potassium is going to lose this electron, so the potassium ion is going to have 3 shells. So let's do it just real quick. So potassium will have 3 shells. And we can see that potassium has dots. So we will use dots too. So, and we will need to put 8 electrons here. All right. And we know that this potassium lost 1 electron, so it has a positive charge. And let's try to do exactly the same with the other potassium, because it's the same. Okay, and 1 plus because it lost 1 electron. Now, the oxygen, this is one of the most important things here. Look, the oxygen has 2 shells, right? We can see that oxygen has 2 shells. And look, that oxygen has crosses, so we will use crosses. But now, look that this oxygen will have 8 electrons, because each potassium gives 1 electron. But say, look that 6 of these electrons will be crosses because they are from oxygen, but the other 2 electrons will be dots because they come from the potassium. So let's put the crosses here. We can combine here like a dot and cross, or we can put 2 dots here. It doesn't matter, actually. But the most important thing here is that you have to put the charge to minus. Now, 3 marks here. 1 mark will be given if the potassium dots are complete. So dots in potassium. 1 mark will be given if you have 6 crosses in oxygen and 2 dots. And the other mark will be given if you have the charges in the correctly. Okay. Now, let's move to the last one for the ionic, and we'll be then learning a little bit about the covalent ones. So remember, all of these are ionic because they have all, or they are all formed between metals and non-metals. Okay. Now, same thing. Sodium electron configuration. So sodium, normally, sodium is 11. So we will have 2, 8, 1. And we have the sodiums because, sodium to O, sodium has charge 1. And oxygen normally is -2. So look that we need 2 sodiums to fulfill the outer shell of the oxygen. So we have 2 sodiums here, 2, 8, 1. So sodium normally has 3 shells. But when they lose this electron here and they become an ion, they have 2 shells. So let's try to put the shells here quickly. Shells. Okay. And we have crosses here. So we continue with the crosses. And we have to put 8 crosses to represent the 8 electrons in the outer shell of each sodium. Okay, and now look that each sodium lost 1 electron, so you put plus, plus. And with the oxygen, we know that oxygen is 2, 6, but it wants to get 2 electrons, so it becomes 2, 8. But this 8 here comes from 6 dots from the oxygen because it has dots, and 2 crosses from the sodium. So in that shell, in the outer shell of oxygen, we will need to put 6 dots that are the electrons of the valence of oxygen, and 2 crosses, each cross from 1 sodium. So here we're going to have, since it got 2 electrons, so we have 2 extra negative charges. Okay, that's pretty much it. Normally, okay, we will skip this one. But normally these ones are always like this. If you note that you have a metal and a non-metal, you have to do this. And remember the 3 things here so you can get all the marks. Now, covalent compounds. The covalent compounds, they are trying to share electrons. And remember that a covalent compound is formed by a non-metal atom plus another non-metal. So in this case, remember, hydrogen is a non-metal and sulfur is a non-metal. Let's see in the periodic table where they are located. And we can see that sulfur is in group 6 and hydrogen is in group 1. So you may think, okay, hydrogen is in group 1, so hydrogen is metal. But remember that hydrogen is the exception for the group 1. So in this case, they are going to share their electrons. So we start doing the electron configuration, and we see that hydrogen is 1, so the electron configuration is 1, but they want to be like helium, because it's the nearest noble gas, which has 2. And sulfur is, let's see real quick, sulfur is 16, so it will have 2, 8, 6. In the covalent compounds and in covalent dot and cross diagrams, you don't have to take into account the inner shells. You just will be working with the outer shells. So in this case, hydrogen will have 1 electron and they want to have 2, and sulfur has 6 electrons and it wants to have 8. So here you can see that if this is a covalent bond, so a bond is a share of electrons. So if you have these kind of intersections here, you start just putting 1 pair of electrons so they can be bonded. It's very simple when you have hydrogens, because hydrogens complete the electron configuration of helium if they share that electron, and sulfur in this case is sharing this cross electron with hydrogen. So we have to check 2 things. The first thing is that all the elements have the valence complete, and if they have the octet complete. If they have these 2 requirements, the exercise is well executed. So in this case, valence means this number, or valence is this number here. 1 or 6 in the sulfur, and those are the electrons that are in the outer shell. Also remember that the valence is given by the group of the periodic table. So elements in group 1a will have 1 electrons in the valence shell. So that's why all the electron configurations of these elements ends in 1. Same thing with group 2, they will have 2 electrons in the valence shell. Group 3 will have 3, group 4 will have 4, group 7 will have 7, group 6 will have 6. Okay, so going back to the valence, we have to check if in this exercise the valence is complete. So we have 6 electrons, 6 valence electrons, and let's say that hydrogen will be working with dots and sulfur will be working with crosses. So in this case, we will need to put 6 crosses in the sulfur. So we have 2 crosses here, and let's try to put 4 more. And okay, now we have the valence, which means that we have 6 crosses here. Look. And we have 6 electrons. And also, we have to check that we have the octet. So we have 6 and 2 electrons that were shared by hydrogen. And now we have 8 electrons in the hydrogen. Okay? Now, let's see what happened with the hydrogen. The hydrogen wants to have 2 electrons And look at this, 2 electrons for the hydrogen. Here we have 2 electrons for the hydrogen, and we have 8 electrons for the sulfur. Okay, so these ones are pretty simple. Even especially when you have hydrogens, it's pretty simple. And take into account valence and the octet. Now, for example, this one, it doesn't have hydrogens. So here we have nitrogen 3-chloride, and we have the information that this is a covalent compound. So in this case, nitrogen is 7, and chlorine here is 9. Let's see real quick. Chlorine is, 17. Chlorine 17. So what happens here is that nitrogen will have the electron configuration of 2, 5, and this will have 2, 8, 7. It's not necessary to do the electron configuration here. Remember, we're just doing it to practice, but we will be working just only with the valence electrons. So we'll have 5 for nitrogen, and let's say that nitrogen works with crosses, and let's say that chlorine works with dots, and we have 7 electrons in the outer shell. Now, what we start doing is, of course, we have a bond here, so we put just a cross and dot, and a cross and a dot. Remember that the less that we will share is at least 1 pair of electrons in the intersection. So I recommend sharing at least 1 pair of electrons in this part here. Okay, that represents that at least we'll have 1 bond. Okay, so since we have this already, and we know that nitrogen is working with crosses and has 5 electrons in the outer shells, so we have 1, 2, 3. So we have 2 crosses left to complete. And let's check the 2 criteria, which is valence and octet. So let's check if nitrogen has the valence 5 electrons, 5 crosses. So 1, 2, 3, 4, 5. So nitrogen has the valence. And let's see the octet. So in the octet, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So we have also that nitrogen fulfills the octet. But now we have the chlorine, and the chlorine is represented here with dots. With these dots, we'll have that we have 7 electrons in the valence shell. So since we have 1 electron here in the valence, and when we have 1 here, we have 2 electrons, but let's focus just to start in the valence. So if we have 7 in the valence, we have 7 dots. So we have 1 here. Let's try to put 6 the outside. 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Now look here. Let's try to see if they have the valence and the octet. In this case, we have 1, 2, 3, 4, 5, 6, 7 electrons in the valence, which is perfect. Chlorine's perfect here. And let's see the octet. So they have 8 electrons, taking the shared electrons into account. So we have 1, 2, 3, 4, 5, 6, 7, 8. So chlorine, and similar in the other ones, they all have 8 electrons in the octet and 7 electrons in the valence. So the exercise is correct. Let's finish with this one. This one is a little bit more difficult, but using the rules that we know already is pretty simple. So let's start with the valence electrons. So carbon is in group 4, so carbon will have 4 electrons in the valence shell, and oxygen is in group 6, so oxygen will have 6 electrons. And let's say that carbon has crosses and oxygen has dots. Now let's start valence and octet. So in the valence, we have that carbon has 4 electrons. So at least one of these electrons from the carbon are being shared with oxygen. So at least one. And let's complete the valence. So we have 4 electrons in the valence. So valence for carbon is correct. Now, in the oxygen, we have 1 here that is being shared. And let's try to put the other 5 electrons to complete the valence. Okay, so it's going to be the same in the other one. So now let's try to check the octet and the valence. Sorry, this is oxygen here. Oh. Okay, and oxygen. So for the carbon, we have that the valence is correct, 1, 2, 3, 4. And let's check the octet, 1, 2, 3, 4, 5, 6. So it's not working with 6 electrons because we need to have 8 in the carbon to fulfill the octet rule. So what we will do is always, every single time that happens, we're going to share 1 electron. In this case, this is called sharing electrons because each atom has to share 1. Okay, so in this case, let's remove this X here and let's put it here. And let's try the oxygen to share 1 electron. So now let's check the valence of oxygen. So oxygen is dots, so we need 6 dots here for this oxygen. So we have 1, 2, 3, 4, 5, 6 dots. So oxygen has the valence. And let's try to check the octet. 1, 2, 3, 4, 5, 6, 7, 8. So oxygen, in this way, in this configuration, oxygen has the valence complete and the octet complete. So we will need to do the same thing here because this oxygen doesn't have the valence or the octet. So when we do this, let's check now. Valence for carbon is 5 crosses. So we have the 5 crosses here. And valence for oxygen is 6 dots. We have the 6 dots here. Same here. And at the end, what we will need to check is the octet. So each atom here has 8 electrons. 2, 4, 6, 8. For this oxygen, same for this one. And the carbon has 8 electrons also. So if they both have the valence and the octet complete, that means that the exercise is correct. Remember that each pair of electrons here represent 1 line. So in this case, we will have C, double bond, O, double bond, O. And this is carbon dioxide. In this case, we will have that only 1 pair of electrons is being shared. So we will have nitrogen, only 1 line, chlorine, 1 line, chlorine, 1 line, chlorine. Okay, guys, I hope this has been helpful for you, and we will see you later.